Okay, so we are in the last lesson in the unit and the last lesson in the course, and that is the binomial theorem. So the binomial theorem is actually very different than permutations and combinations. The binomial theorem, the formula that we'll be using, actually stems off the Pascal's triangle. The coefficients that you would use in the binomial theorem, if you didn't have coefficients for each variable, okay, are the numbers you would see in the Pascal's triangle, depending on the row that you were looking at. We're not going to get into that too much. We're mainly just going to be looking at how to apply the formula. So once again, this formula is on your formula sheet, and we will be referring to it throughout the lesson. Okay, so a few things before we get started. The k value will always be 1 less than the term. That's why it says t is k plus 1, because k is 1 less than the term. Okay, so determine the fifth term of x plus y 8 to the power of 8. All right, so when we look at this formula, we're going to actually make a legend. So we're looking for the fifth term, which means t equals 5. I'm going to see if I can write that a little neater. So t equals 5. So that means k has to be 1 less than t, so then k would therefore have to be 4. All right, and then n is always going to be your exponent. So my exponent here is 8, so my n value is 8. Now that I have my legend made, all I'm going to do is fill in my formula. So I'm looking for the fifth term, so t5. My n value is 8, so I'm going to write 8. C, my k value is 4. My first term, so this x always represents the first term. So the first term here actually ends up being x, so it's pretty easy. And then n minus k, so 8 minus 4. And the y represents the second term, which in this case happens to be y to the power of 4. So on my calculator, I'm going to type this 8 choose 4. So go ahead and type that in, and you should get 70. 8 minus 4 is of course the power of 4, and y to the power of 4 is 4. So because I have no exponents inside of my brackets here, okay, actually my exponent should end up adding to the n value, the 8 on the outside of the brackets. All right, so that is my fifth term. Let's try another question. So this time we're looking for the middle term. So once again, let's start by making our legend. So the middle term, okay, the other thing we need to talk about is your n value here is 10. You will actually end up having one more term than whatever your n value is. So if I were to expand this whole expression out, I'd end up with 11 terms. Okay, so in total, if I were to expand it all out, I'd have 11 terms. And actually, I can go back to the first slide. So do you see how you have x plus y to the power of 5? If you count, you have 1, 2, 3, 4, 5, 6 terms. So you always have one more term when you're in expanded form, than whatever the exponent is. Okay, so if I have 11 terms then, okay, my middle term would be term 6 because I'd have 5 terms before it and 5 terms after. If my t value is 6, that means my k value has to be 1 less than 6, which would be 5. So now that I have this, I'm going to fill in the formula. So I'm looking for my sixth term. My n value is 10. 10, choose my k value is 5. X to the power of 10 minus 5. And y to the value, except for this time instead of x and y, whoops, I should have a and b, right? Because those are what my terms are. Let's fix that really quick. Okay, to the power of k, which is 5. So on your calculator, you would type 10 choose 5. If you type that in, you should get 252. 10 minus 5 is of course 5, so then I have a to the power of 5, b to the power of 5. There we go. All right, use the binomial theorem to write the expansion. So now we're actually going to write the whole expansion here. So when you start, I always suggest try writing that legend again, at least for your first few terms. So let's start with term 1. So that would mean my k value would be 1 less, which is 0. And my n value would never change, it'd be 7. So I'd have x plus y so the power of 7 equals, my first term is 7, choose, and of course I'm going to actually write this down over here, and choose k, x to the power of n minus k, yk. So I'd have n, choose 0, my first term is x, easy enough, n minus k, 7 minus 0 is 7, and y to the power of 0. Notice how the 7 plus 0 adds to 7. Okay, so now we're going to do the second term. So my t value is 2 and my k value is 1. So now I have 7, choose 1. X to the power of 7 minus 1 is 6. Y to the power of 1. Now I'll do my next term. So I'm doing term 3. So I have 7, choose 2. X to the power of 7 minus 2 is 5. And y to the power of 2. And I'm running out of room here, so I have 7, choose 3, x to the power of, oh, we're doing our fourth term. Okay, and you might notice a pattern here. Notice how the x value of the exponent's always going down by 1. And the y value of the exponent's always going up by 1. So generally for me, after I've noticed that pattern, I will probably stop making the legend and I'll just continue to fill it out. Now I have 7, choose 4. My x goes down by 1, so it's x to the third. The y goes up by 1. 7, choose 5. X to the power of 2. Y to the power of 5. 7, choose 6. X to the power of 1, y to the power of 6, and 7, choose 7. X to the power of 0, and y to the power of 7. So if you were to count all of these terms up, you should end up with 8. We're not quite finished though. You can't leave the combination symbol. You actually have to type that in your calculator. So I know 7, choose 0 is 1, so really I end up with just x to the 7th. 7, choose 1 is 7. 7, choose 2, if you type that in your calculator, gives you 21. 7, choose 3 on your calculator would give you 35. 7, choose 4 also gives you 35. 7, choose 5 gives you 21. Notice how this is symmetrical. 7, choose 6 gives you 7. And 7, choose 7 gives you 1. All right, we're all finished. So that's what it ends up looking like in expanded form. So now we're moving on. So now you're going to see you have coefficients. So this makes it a little trickier, but we're only going to find the fifth terms. We don't have to expand the whole thing out. So again, I'm just going to write that formula up top here. Okay, so let's write our legend. Our t value, we're trying to find the fifth term, which means our k value would be 4, and our n value, of course, is that 7. So when I write that out, I'm looking for term 7, or term 5, sorry. I would write 7, choose 4. Now x is your first term. My first term is 3x, so I'm going to put that in brackets. 3x to the power of 3. The reason it needs to be in brackets is you need to realize that that exponent of 3 also applies to the coefficient of 3, not just the variable. Okay, and then I have y, which is my second term, which in this case is the negative 2y to the power of 4. Okay, so now what we're going to do is we're going to type 7 choose 4 in our calculator, which gives us 35. We're going to type 3 to the power of 3 on our calculator, which gives us 27. And then on our calculator, we're going to type negative 2 to the power of 4, but that negative 2 needs to be in brackets. So we end up with positive 16 y to the 4th. So now that I've figured this out, all I'm going to do is multiply these coefficients. I'm going to times 35 by 27 by positive 16, and I end up with an answer of 15,120 x to the 3rd y to the 4th as my final answer for term 5. All right, next question. Determine the numerical coefficient of the term containing a to the 7 in the expansion, 3 minus a to the 10. So this one is trickier because we fill out our legend. We still know n equals 10. Whoops. But we actually don't know what term we're looking for. So let's start by filling out the formula again. So we don't know the term. We know it's k plus 1. We have 10, choose k. Our first term we know is 3 to the power of 10 minus k. And our second term is negative a. But if I have a to the 7th, that means I need a coefficient of 7 here. Since that exponent is 7, it represents my k value. So that means k has to be equal to 7. So let's backtrack here and fill in all the k's. Okay, so now I know I'm looking for term 8 because 7 plus 1 is 8. And wherever I see a k, I'm going to put a 7. Great. Okay, so if I were to type 10 choose 7 on my calculator, let's go ahead and type that in. 10 choose 7. We end up with 120. 3 to the power of 3 gives me 27. And then remember, you would pretend like there's a negative 1 here. So that way you know if this term should be negative or positive. Okay, so a negative 1 to an odd exponent is negative. So I end up with negative a to the 7th. All right, now let's multiply these coefficients. So 120 times 27 gives me 3,240. And of course, it should be negative. And there we go. So the numerical coefficient would therefore be negative 3,240. All right, we have a couple questions left. Determine the constant term in the expansion of 2x minus 1 over x squared to the 15th. So there's definitely a lot of different ways you can do this. What I'm going to do is we need to figure out the constant term. So constant means where there's no variables. So really, I want to figure out where these cancel out. So if we were to expand this all out, remember how we talked about, oh dear, n minus k, y to the power of k. Remember how we talked about how your x value ends up decreasing by an exponent each time and your y value increases. So I'm actually going to take a shortcut version here just to figure out what term I'm looking for. So I'm not going to worry about the n choose k. Okay, all I'm going to do is take my exponents. So for my first term, I'd have n to the power, my first term would be 2x to the power of 15, right? Plus, my next term would be 2x to the power of 14 and negative 1 over x squared to the power of 1. Okay, so here I'd end up with x to the power of 14 on my numerator and x squared on my denominator, so they would not cancel out. My objective here is I'm trying to figure out which term do they cancel out. So not term 2. Let's try term 3. So now if you were to apply this exponent, you'd have x to the power of 4, right? Because you would end up multiplying them. So I'd have x to the 13 in my numerator, x to the 4th on my denominator. They still haven't canceled out. So that means I'm going to need to move to term 4. Okay, now I have 6 on my denominator and 12 in my numerator. Still doesn't cancel out. Term 5. Now I have 11 on my numerator, 8 on my denominator. Still doesn't cancel. Term 6. Okay, and look, we have a winner. So we know term 6 is where they cancel out. So all I've done is I've kind of taken a shortcut to get to that term, okay, instead of expanding it all out. So now that I know it's term 6, I will properly use this equation. So term 6 means my k value is 5, and I'll fill in the equation. And of course my n value is 15. So I'm going to write 15, choose my k value is 5. My x value is the first term, which is 2x to the power of 15 minus 5 is 10. And then my second term is negative 1 over x squared to the power of 5. Okay, so to start with, 15 choose 5, if I type that in my calculator, I should end up, let's try typing that in. I end up with 3003. Two to the power of 10 gives me 1024 x to the power of 10. So now negative 1, remember that negative also applies to the exponent. Negative 1 to the power of 5 would actually just end up being a negative 1. Okay, and then I have x to the power of 10. So of course those x10s canceled out. That's why I chose this term. The negative will still be there. So really I have 3003 times 1024 times that negative 1, which gives me a huge number, negative 3,075,072 as my final answer. All right, and you may find a different strategy to solve this. This was the strategy that I found easiest. Okay, last question, actually probably the easiest one to finish with. Find the value of a if you know the expansion of this term here has 18 terms. Okay, so I know the expansion of this binomial, has 18 terms. So that means the exponent has to be 17, because remember how we talked about how the n value, right, is always going to be 1 less than the amount of terms in your expansion. So that means 2a minus 5 has to equal 17. Now that we know this, okay, it's pretty much grade 8 math here. We're just solving for a. So I'm going to add that 5 to the other side and get 22. Divide by that 2 and I end up with 11. So a equals 11. Definitely try some questions here. Make sure you understand how the binomial distribution works and let me know if you have any questions about it.